Let's talk about handles now. What is a handle? Well, a handle is basically something that represents or actually references to a given object. In our case, we will use handles to reference our plots. That way, we can later change the properties of these plots. So if we take one of our plots, let's take the first plot that we have, and we assign this to a variable name, we create a handle for that plot. Let's say that this is the carp, so let's say carps plot handle equals to that plot, and we must suppress the output at the end because this will now generate an output. We are creating an object. Down here we can say, let's run it first. You can see that when we run it, absolutely no differences. We get the exact same plot, but in our workspace you can see that we have carps plot handle, which is of type line. It's now of type line. So we can use this handle to change the properties of that specific line. We can say, to do this, we are using the set function. The set function takes three arguments. It takes a handle, so that it knows on which thing to apply the new properties, and it also takes a name value pair arguments. So we can say carps plot handle. We can change the width and the color of that line. So we can say line width of 2, and we can also change the color. So carps plot handle color, let's make it, I don't know, let's say red. And let's run it. There we have it. As you can see now, the first line that we have in our plot, that's the carbohydrates line. It's now a bit bolder, it's a bit thicker, and it also is in red color. And these properties applied only to that plot because we have handle only for this specific line. The rest of the lines, these two plots, do not have handles. We have not touched them, not yet at least. Now you may say, that's good, but can't we just use these name value pair arguments in our plot function and be done with it? And that's a good point. Initially, yes, you can do it. You can write a comma here and say line width of 2, color red, and it's going to work. What if later in your code you decide that you want to change these properties of that same plot? You will do it by using a handle and the set function. Otherwise, you have to replot everything with these new properties. Now, a handle can be assigned either to the plot itself, the line, as we just did, or the subplot. And each of them controls different properties. As you can see here, I showed you earlier that this handle that we created with our plot is of type line. When we use the handle of the line function, that handle is responsible only for the line that is created by that plot function, only for its specific line. So it's called a line handle. If we give a handle to the subplot itself, that handle will represent the whole subplot, or it's actually called an access handle. So we can say all nutrients, since this subplot represents all nutrients, so all nutrients handle equals to the subplot, suppress the output, and if we run it again, you will see down here that now we have something of type access. Access handles are superior to the line handles. So all of the lines that are within a given subplot or within a given axis can be accessed through the access handle. The lines are children of the axis. So let's give each of our subplots an access handle, and let's document our code a bit so that it's a bit more readable, because currently I get lost in the code very easily. Now, first we have our base lines, then we have our initial data. This is initial data, some data that is generated, baselines, then we have all data in a single plot. Then we have, actually this is a subplot, then we have our carbs second subplot, then we have protein third subplot, then we have the fat fourth subplot, and finally we have the calories, which is the fifth subplot. Now, down here we have properties of the subplots. Now, let's give handles to each of our subplots So here we have all nutrients handle. Actually, we saw that this is an axis. So let's just rename it to all X. X short for axis. Here we have carbs X. Then we have protein X, fat X, and we have two more, so calories X, and then we are done. Alright, so what can we do with all of these axes? We can use all of these axes in a vector. We can create a vector from all of these axes, and we can change the properties of all of these axes simultaneously. So we can say x equals, and here we list all of the axes. So all x, carbs x, protein x, fat x, and calories x. Now, why am I doing this? I'm doing this because the first thing that I'm going to change is the x limits of our plots. As you can see, they all start from 0 and end at 14. I want them all to end at 15. And when it's minimized, you can actually see that it starts at 0 but ends at 20. I want them to be from 0 to 15. Now, what I can do is write xlim 0 to 15 on each of these subplots. So I have to write it 5 times. But what I can alternatively do is use the set function to set the limits by using the axes, the vector of axes. So I can say set x, xlim with a capital X, and I can give it the limit that I want, so 0 to 15. And if I run this now, you can see that all of these graphs, all of these subplots have the 0 to 15 limit. No matter whether they are maximized or minimized, they have this limit. But if I try to change the line width, for example, of these subplots, you will get an unexpected result. Line width. You probably expect that all line graphs will become a bit thicker, but that is not what happens. As I said earlier, the lines have their own different handles. They are of type line. As you can see, each of the subplots, the borders of each of the subplots became thicker. So by using the line width on the axis of the subplots, we changed the thickness of the border of these subplots. Now, similarly, we can use the same approach. Let's delete it. The same approach to turn the grid on for all of these subplots. So set x. We have to turn both the x grid and the y grid, and the same for the minor grid. So x grid on, y grid on, and we can do the same thing for the minor grid. So set x, this will be x minor grid on, and then we have y minor grid again on. And if we run it, we can see that now all of these subplots have both the bigger and more rare grid, and we also have the minor grid enabled for all of them with just 2 lines of code. If we wanted to turn on the grids for all of these subplots, we would have to write 10 rows of code. Grid on, minor grid on for each of the subplots. So the benefits of having and using handles are pretty obvious. Now I want to show you a few other things, and we will end with the project.